Hello, grade sevens. In today's lesson, we are going to begin a new unit of study on probability. And in this unit of study, we're actually going to draw upon the knowledge we gained in some of the previous units where we were dealing with some basic fraction operations and also converting between fractions, decimals, and percents. Albeit this time, we're going to take those concepts and apply it to problems you might see more so in a real world type context. Learning outcome for this lesson is to express probabilities as ratios, fractions, and percentages. But we're going to start off with a definition of what probability is. Probability is defined as the likelihood or chance of a specific event occurring. I want to give a few examples of different types of events and what the probability would be like for these events. One of the most simple objects you can use to illustrate probability is a two-sided coin. If you were to flip a two-sided coin, there's two outcomes. Either you're going to get heads or you're going to get tails, unless like there's a really unlikely scenario where like the coin lands on its side, but we're not going to consider that. So if I said what exactly is the probability of flipping this two-sided coin and landing on heads, well, you'd have a 50% chance of landing on heads. If you were to take that 50% chance of landing on heads and convert that into a decimal, that would be 0.50, which you could get by taking 50% and either moving the decimal spot 2 units to the left or dividing by 100. And if we were to convert that into a fraction, and a fraction that could be reduced, that fraction would be 1 over 2. So there's a 1 over 2 chance that when you flip a two-sided coin, you could get heads. A standard deck of cards has 52 cards in it. So you have an ace, you have 2, 3, 4, 5, 6, 7, 8, 9, 10. You have a jack, you have a queen, and you have a king. And then for each of those cards, you have, for example, a king. You have the king of hearts, the king of clubs, the king of spades, and the king of diamonds. So if I wanted to calculate the probability of drawing a king from a standard deck of cards that has 52 cards in it, we're not going to worry about the jokers. Well, we'd probably set this up as a fraction first. So again, there are 4 kings in this deck of cards. And the king of diamonds, king of spades, king of clubs, and king of hearts. So the probability of drawing a king from that deck of cards would be 4 over 52. When you have a fraction 4 over 52 and you want to turn it into a decimal number, you simply just divide the numerator by the denominator. So 4 divided by 52 would give you a decimal number. And if you round it to the nearest thousandth of a decimal, it would be 0.077. And to convert that to a percentage, well, you'd multiply the decimal number by 100. This one's more of a joke, although albeit a very sad joke. When I first wrote this PowerPoint presentation, it must have been somewhere around 15 years ago, where the Edmonton Oilers hockey team was not very good. And I wrote this in here as a joke, just basically to say what's the probability that the Edmonton Oilers can actually win a hockey game, and it's equal to 0. Well, 15 years later, there's not a whole lot has changed. As I speak right now, in the year 2022, the Oilers, I think they've lost something like 8 of their last 12 games and are on a 5-game losing streak. So sadly, the probability of the Oilers winning a hockey game is still probably pretty close to being equal to 0. There's only so much you can actually enjoy the suffering of a sports team before you just want them to start to actually do better and to win games. And I'm at that point, the Oilers now. I'd like to actually see them win hockey games. What we want to do is we want to calculate probability. And to calculate probability, we have the following formula. So the formula is you have P, and then in brackets, A is equal to, we'll define what that means in a moment, what the P bracket A is. P bracket A is equal to the number of favorable outcomes divided by the number of possible outcomes. This equation will make more sense when we go through an example problem in a moment. A possible outcome is just in a particular experiment, like all different, the number of different possibilities you could actually obtain. So if you go to, for example, the coin, the number of possible outcomes would be two. Yeah, you can either get heads or you can get tails. The favorable outcomes is the outcome you actually want to get. So in the case of the coin, when you flip the coin, there's only one way you can get heads. Therefore, if you wrote the favorable outcomes and the possible outcomes into this equation for a coin, the probability of flipping a coin and getting a head and getting heads would be 1 divided by 2. As for going to the deck of cards, well, for a deck of cards, you have 52 possible outcomes because you have 52 unique cards. If I want to draw a king from the deck of cards, the number of favorable outcomes is the number of ways I can actually get what I want, which is a king, and that is 4. Therefore, the probability of drawing a king would be 4 divided by 52. We're going to abbreviate this, though. Instead of because when we get into the work in a moment, I'm going to expect that you do write down the equation to start off with. Although instead of writing down the entire words favorable outcomes or possible outcomes, we'll just abbreviate it as FO for favorable outcomes and PO for your possible outcomes. On the left-hand side where you have P bracket A, P is an abbreviation for probability, and this is a very general way of defining probability. When it says P bracket A, it means the probability of event A occurring. Now, that's not specific at all because you immediately be like, well, what exactly is event A? Well, depending on the situation you're dealing with, you're gonna change what's actually in the brackets. You can see up here that when I was looking at flipping a coin and getting heads, I wanted to get heads, so I replaced the A with heads. Or when I was going to draw a card from a deck of cards and I wanted a king, I want to know the probability of drawing a king, so I replaced the A with a king. Okay, so that's what we're always going to do. We're in brackets. We're going to clarify what's the favorable outcome that we're trying to get. Two notes here. 1, probability of event A occurring is equal to 0 or 0%, then what that means is that the event is impossible. So if you look at this illustration, this is a picture of a spinner where the spinner is divided into 3 areas. In one area you have the letter A, in one area you have the letter E, and one area you have the letter U. An impossible event in this situation would be, for example, if I said the probability of spinning the spinner and getting the letter G, that would be equal to 0 because there is no G there. Therefore, the probability of that event occurring would be 0, and the event is actually impossible. There's no way to actually get a G. If the probability of an event occurring is equal to 1, or if you converted that to a percentage by multiplying by 100%, then that means the event would be certain. So if I said here, what's the probability of spinning the spinner and getting a vowel? Well, A, E, and U, they're all vowels. Therefore, the probability of doing that would be, if we go into our equation, so it'd be like favorable outcomes over possible outcomes. There's 3 possible outcomes, an A, an E, or a U. How many ways can you get a vowel? So the number of possible outcomes is 3. The number of favorable outcomes is also 3, okay, because you can get an A, an E, or a U. 3 over 3 be equal to 1. And if you turn that into a percentage, that would be 100%. In that situation, we would say the event is certain. So the probability of spinning this thing and getting a vowel, that would be 100%. All right, let's look at an example where we calculate this in a bit more detail. So I have a hat, and it contains a bunch of pieces of paper that have letters that are the piece of paper that has the letters M, R, V, R, U, L, E, S all those letters are cut into individual pieces and they're placed in the hat and mixed up. A person sticks their hand into the hat and randomly draws out one letter, and I want to calculate the probability of pulling out the following letters, and I want to express as a fraction, decimal, and the percentage, and round all these percentages to the nearest tenth Okay, so let's start off with this. What's the probability of drawing the letter E from this hat? Okay, well, let's set up the equation. So we're going to write down the probability of sticking your hand into the hat and drawing a letter E. So always in brackets, we identify what we're trying to get. We want to get the letter E here. This would be equal to the number of favorable outcomes over the number of possible outcomes. Now, if you look at the number of possible outcomes, that'd be the total number of letters you can actually get here. The total number of letters would be 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 possible outcomes, 8 possible letters you can pull out. Now, in terms of the number of favorable outcomes, well, how many ways can you actually get an E? Well, there's only one E in the hat, so the number of favorable outcomes would just be 1 over 8. Now, I also want to express this as a fraction, a decimal, and a percentage. So I have the fraction, it's 1 over 8. Now, to express it as a decimal number, what you would do is you'd plug this into your calculator as 1 divided by 8. That's what a fraction is. A fraction is just division. Okay, 1 divided by 8, if you do plug it into your calculator, would give you 0.125, which is a terminating decimal. And then, if I want to convert this into a percentage, all you have to do is take this decimal spot and move it 1, 2 units to the right, which is equivalent to multiplying by 100, and that would then be 12.5%. So the probability of drawing an E out of this hat would be 1 over 8 as a fraction, 0.125 as a decimal, and 12.5%. Okay, how about the letter R? Well, let's set the equation up again, and you must show this work, by the way. Okay, so we're going to write down the probability of drawing an R from this hat would be equal to the number of favorable outcomes divided by the number of possible outcomes, so FO over PO. Okay, once again, the number of possible outcomes, you're still drawing from the same hat, so you still have 8 possible outcomes. Now, the number of favorable outcomes would be how many ways can you actually get an R? Well, you have 2 of them, okay? So this would be 2 divided by 8. If you plug 2 divided by 8 into your calculator, you would actually get 0.25, which is also a terminating decimal. And if you turn that into a percentage, it would be 25%. Now, I know the problem says round the percentages to the nearest tenth, but so that would technically be 25.0%, but it's already a terminating decimal, so there's really no reason to add that 0.0 to the end. This is more of an issue if you have a repeating decimal number and you need to round it. Okay, how about drawing a consonant from this hat? Now, in case you're not aware of what exactly a consonant is, consonants are all the letters of the alphabet that are not vowels. So that could be any letter of the alphabet with the exception of the vowels A, E, I, O, or U. Okay, so let's look at this, and I'm going to try to change the color here. Okay, let's identify what all the consonants are. So M is a consonant, R is a consonant, V is a consonant, R is a consonant, L is a consonant, and S is a consonant. So you have 6 consonants. Okay, so let's go back and let's calculate this now. So we'll set up my equation. So my equation is the probability, and in brackets here, I'm going to say of getting a consonant is equal to, and again, we need to show this work. This is equal to the number of favorable outcomes over the number of possible outcomes. You're still drawing from the same hats. You still have 8 possible outcomes. And then the number of favorable outcomes would be the number of ways you can actually get a consonant. So again, there's 1, 2, 3, 4, 5, and 6 of them. So you have 6 over 8. If you calculate this, so that'd be 6 divided by 8. You can plug it into your calculator. There's no reason for us to do the long division work here. Our emphasis is more on just doing these calculations quickly as opposed to doing it by hand or using mental math to do them. So 6 divided by 8 would be 0.75. So there would be a 75% chance of drawing a consonant from this hat. Let's do one more example. So we have a bag that contains 3 blue marbles. So I'll just illustrate this. So we have 1, 2, 3 blue. We have 2 red marbles. And we have 1 green marble. Okay, a person draws out a single marble at random, and I want to calculate the probability of pulling out the following marbles and express as a fraction, decimal, and a percentage, and also round all percentages to the nearest tenth of a decimal. Okay, so I want the probability of getting a red or a blue marble. So I'm going to write down probability of B or R. We'll abbreviate B for blue and R for red. We can do abbreviations just to save ourselves a little bit of work here. Okay, that's equal to the number of favorable outcomes divided by the number of possible outcomes. How many possible outcomes are there? There's 6 different marbles you could pull out, so that would be 6 for possible outcomes. Now, how many favorable outcomes could you get? Well, what this is saying right here is that it is acceptable to have blue or red. So we're going to count the number of blue and red marbles all together. So if you look up here, we have 1, 2, 3 blue and 1, 2 of these red ones. So you have 5 over 6. Now, when we calculate this is actually going to give us a repeating decimal number. So we're going to have to do a little bit of rounding with this one. So if I plug 5 over 6 into my calculator, you're actually going to get a repeating decimal that looks like 0.8333333, and this will fill the calculator screen up. Now, what I want to do is for these decimals, I want to round them to the nearest thousandth of a decimal place. So the nearest thousandth of a decimal place is 1, 2, 3. It is the third decimal place right here. So it's this one. Now, when you round to this decimal place, you have to look at the following digit because the following digit is going to tell you whether you need to round this digit up or not. So if you look at the digit that follows, if the digit that follows is either 0 through 4, it means you do not round this digit up. You just leave it as a 3. If that following digit is a 5 through a 9, then you would round it up by 1. But in this case, a 3 follows, so that's a digit between 0 and 4. You do not round it. So you're just going to leave it as, to the nearest thousandth of a decimal, 0.833. And then to turn this into a percentage, you just multiply by 100, and then this would give you 83.3%. B, what's the probability of not pulling out a red marble? Well, you just have to just think about this. Like, what does it mean to not pull out a red marble? So not pulling out a red marble would mean that you can either have blue or green. So it'd be okay to draw blue or green. So then this would be the probability of getting blue or green would be equal to Again, we'll write our equation down. Again, we want to show this work. We want to be able to communicate our written work. So we have F over PO, and that is equal to the number of possible outcomes. Once again, there's 6 marbles. Now, how many ways can you either get a blue or a green? Well, it's counted. You have 1, 2, 3 blue, and you have 1 green. So that would be 4 over 6. Now, if we calculate 4 divided by 6 into our calculators, this is also going to give us a repeating decimal number. So this time around, it's going to give us 0.6 repeating. So 0.66666, etc. Sorry, I don't know why it's doing those vertical lines there. That's okay though. Okay, now once again, we want to round our decimals to the nearest thousandth. That's going to, if we round our decimals to the nearest thousandth, then it'll make our percentages to the nearest, usually it'll make the percentages to the nearest tenth of a decimal. Okay, so we want to round to this number right here. Now to do that, once again, we have to look at what digit follows. Now the digit that follows is a 6. So that's a number that's 5 through a 9. So in this case right here, what we have to do is, because the following digit is a 6, we have to round this thousandths digit up by 1. So this would then become 4 divided by 6 would be 0.667. And if you multiply by 100 to convert it into a percentage, it would then be 66.7%. And that allows me to get the percentage to the nearest tenth of a decimal. This is more of an issue, rounding to the nearest percentage to the nearest tenth of a decimal, if you got a repeating one. If you got a terminating decimal, then you don't really need to worry about this. All right, that's it for this lesson, where we are just calculating the probability of a single event occurring. And you can practice this by completing on page 163, numbers 3 through 8. I did want to make a note, though, that the textbook in every single question says to write the answers as a fraction, ratio, and a percentage. Ignore the part where it just says ratio. And what you want to do is, for each of these, is just how I modeled it in the example problem. You want to express it as a fraction, a decimal, and a percentage. Okay, so just replace the word ratio with decimal. They don't mean the same thing. The ratio is different from a decimal, but we're not going to worry about a ratio right now. Ratio is typically, most ratios are expressed as fractions anyway, so we're already doing that regardless. So just all answers as a fraction, a decimal, and a percent. And if it's a repeating decimal number, round those decimals to the nearest thousandth and round those percentages to the nearest tenth of a percentage. And I'll talk to you in the next lesson.